Hi, Assalamualaikum. My name is Siti Lailatul binti Muhammad Hassan. I will present this paper FPGA-based edge detection technique with image filter enhancement. Okay, so what is edge detection? Edge detection is one of the technique for image processing to find the edge for every possible object exists in an image. Okay, the point is which the brightness of the image changes sharply is usually grouped into a collection of curved line segments called edges. Edge detection is an essential tool for image processing, machine vision, and also computer vision, particularly in feature detection and extraction. Okay, what is the commonly used algorithm for edge detection is a Sobel operator. This is because Sobel have the ability to detect almost all boundaries in an object in one image, either in static or in real time. What is the problem with the current Sobel operator used in edge detection? So the first problem is that the quality output of the output image from the Sobel filter has a significant blur in certain area. The second problem is that the gradient distribution in grayscale is not constant in a high noise environment. And the third problem is that detection of edge is not reliable with only just one filter. For that problem, we come up with three objectives. The first objective is to increase the image quality and smoothness by applying four different filters, which is Gaussian, median, sharpening, and downsampling filters. The second objective is to reduce noise in image output as well as distortion in a real-time image. And the third objective is to detect edges of objects as close as possible to their original exterior structure. For the scope of work, the algorithm used for the edge detection for this paper is the Sobel operator algorithm. And the filter used for this paper is Gaussian filter, median filter, sharpening filter, and downsampling filter. Well, for the hardware, we use DE115 FPGA board, TRDB D5M CMOS camera, and also a VGA monitor. Okay, this is the hardware setup for the experiment. Okay, this is the VGA board. We have the FPGA board here, and this is the camera. Okay, first we focus on one object, which is the keyboard, and we take the picture using the CMOS camera, and then we do the data processing in DE115 FPGA and display it on the VGA monitor. Okay, if you can see from the flow chart, each of these filter is connected to the switch. Okay, when we want to turn on the Gaussian filter, for example, we just turn on the switch 1. And then we can turn on the video filter using switch 2 and so on. Okay, for result in this okay, this is the image quality result. Okay, before we proceed into further analysis, we need to convert the normal RGB picture into a grayscale. Okay, this is the conversion to the grayscale from the RGB image. And then the first step, we turn on the Sobel operator. Okay, we just focus for the image in the red circle. Okay, you can see that when we turn on the Sobel, the image is still blur. Okay, and then we turn on Sobel and also the Gaussian, just one Gaussian filter. You can see that the image become more blurry and because the staticness increase. Next, we just turn on the Sobel and median filter. As you can see from this picture, we cannot recognize the image itself. It's just like a dot of black and white. And then we turn on Sobel and sharpening. Okay, using the filter, you can see that the edges of the image quite improve. And then we try to turn on the Sobel and downsampling. You can see that the edges improve as well as the noise. Okay, next we try to turn on several filters at the same time. Okay, when we turn on Sobel, Gaussian and Sharpening, you can see that the edges improve, but you can see here that the image is blur around here, and the noise is quite high. And then we try to turn on Gaussian, Median and also Sharpening. Okay, the edges quite improve, but you can see the noise also increase over here. This is particularly mostly because of the median filter. Okay, and then we have the Sobel. We turn on all the four filter with Sobel. You can see here no more noise around here. It means that the noise is reduced, and we can see clearly the edges around here. Okay, then we proceed to the power consumption analysis. We can see if no filter used, the power consumption is quite high, which is 351. And then when we turn on the filter, the thermal power reduce to 350 only. And as you can see, if you just turn on one filter, the power will reduce. But we don't want to just use one filter, because we can see from the image quality, the image is not so good if we just use only one filter. Okay, this is the total element used on the FPGA board. Okay, if you, as expected, if you don't use any filter, yeah, the number of total logic element used is lower. But if we turn on all the filter, it will become 2 times larger. And if you just use one filter, it is slightly increased number of total logic element compared to no filter. But we don't want to just use one filter, as I mentioned earlier, because the image quality is not so good. In conclusion, image quality from Sobel operator will improve by applying several types of filter into each detected image. The quality varies depends on number of filter active and the nature of the filter itself. Static and noise display by the VGA monitor were reduced with noise reduction filter such as sharpening filter and also downsampling filter. Moreover, each detect considerably alike to the real object. Details such as shape gradient, size in length and width, and grayscale conversion are satisfied when most filters are active. That's all for me. Thank you.